Well, hello, and welcome to this AutomationWorld webinar. I'm David Greenfield, Director of Content for AutomationWorld, and I'll be hosting this event. Now, if you're not entirely familiar with the concept of virtualization, don't feel bad. It's a relatively new concept in the industrial space, and it's been gaining a lot of attention recently, not only because it allows users to optimize resources and maximize uptime by making technology deployments more agile, but also because it helps reduce risk by allowing you to test out and prove the viability of specific operations before deploying them in real life. Now, since HMI SCADA systems are such common industrial automation technologies, explaining virtualization in an HMI SCADA context is a great way to help understand the concept. So joining me today for this webinar are Ozan Ferrin, Supervisor of Generation Automation Engineering at Tacoma Power, and Gimmi Filice, Manager of HMI SCADA software at GE Digital. Now, Ozan will explain how the team at Tacoma Power successfully deployed a multi-phase HMI SCADA virtualization project across its hydroelectric and fish hatchery facilities. Now, also in this webinar, we'll cover a comparison of the benefits of a virtual environment with traditional practices, how to build the business case for moving to virtualization, how Tacoma Power successfully moved from a traditional HMI SCADA environment to a virtual one, how to maximize the benefits of virtualization, such as cost savings and reduced risk, and how to put a plan in place for evaluating and deploying virtualization. Now, at the end of the presentations, we'll also have a question and answer session with the audience. So now I'll go ahead and turn over the webinar to Gimmi.
All right, thank you, Dave. So as Dave mentioned, today we're going to discuss how utilizing virtualization can help you reduce your cost of ownership and risk associated to HMI SCADA systems. So we can start by looking at essentially the definition of what a virtual machine is. So if you Google virtual machine, you're going to get something that sounds like this, where a virtual machine is an operating system or application environment that is installed on software, which imitates dedicated hardware. So ultimately what this really means is you can actually have multiple operating systems running on the same hardware utilizing software technology that's essentially going to allow them to run independently and share that hardware. So if we look at just general trends around virtualization, if we consider the IT space has been rapidly adopting this technology now for several years. And based on a recent report, as you can see there, you've got about 75% of actual workloads of Intel-based systems actually now running on virtual hardware or virtualization environments on hardware. And the most popular ones are VMware and Microsoft today. If we look in our own industry, it's essentially less than 30%. It's still at its infancy and growing within the market. And obviously today we're going to talk about some of the good reasons why it should be adopted in our market as well. So if you look at just this simple graph, and what we're trying to really illustrate here are, if you look at a typical system, whether it's a SCADA system or even some of the other systems that are used with your automation software, you'll often find if you monitor the CPU usage on a single system, it's actually not being used all the time, and you'll just get the occasional spike of usage here and there, really depending on the application load at any given time. Really what this is, especially today with all the multi-core systems, really you're just wasting all the resources of the hardware that you purchase by not making better use of it. If you consider it with in the contrast of a virtual server environment where you've got multiple sessions running on the same piece of hardware, you can essentially get the full usage of your hardware by leveraging virtualization. So if I look at just some of the key capabilities or key outcomes of virtual machines, we could start with partitioning, and really what this means is being able to have multiple operating systems on the same physical machine. These can actually either be the same operating system, and for example, you could have multiple Microsoft operating systems like Server 2012 or what have you, or it could actually even be different operating systems like a Linux machine and a Windows machine essentially sharing the same hardware and really running in their own space. Another concept around virtualization is isolation, and really what this ultimately means is that they are running independently from each other. So what happens in one session isn't really impacting what's happening in the other. So this really helps essentially create a separation between those environments, no different than having two physical pieces of hardware running that way. One of the key other cool things is encapsulation. So, you know, the fact that you can actually take a virtual machine, save it, it's essentially a big file that can be saved, copied, backed up easily. You can create snapshots at any given time of how the system's running. Really, some of the key advantages around that are the fact that you can easily back things up. You know, if something does fail, it's a matter of taking that virtual machine copy, putting it on another piece of hardware with the virtual machine software on it, and starting up and running right away. So there's some definite benefits even just from a you know, recovery perspective. And then hardware independence. You know, as many people know, as you move from one piece of hardware to another, there's different hardware, different drivers, different physical parts of the system that are involved that the operating system needs to deal with. By utilizing virtualization, you're going to get hardware independence. So, you know, whether it's a Dell, HP, or whatever the various different hardware platforms are, by having the virtual machine there, it essentially isolates the operating system from that hardware. From the actual operating system perspective, it sees it all as the same. So those are just some of the key capabilities of the system. So with that, I'm going to hand it over to Ozan to review kind of the benefits he's seen at his business around virtualization.
Thanks, Jimmy, for that preview of some of the things, some of the benefits and capabilities of that virtualization. Just by way of reminder, my name is Ozan Ferrin. I'm a supervisor for generation automation at Tacoma Power. I'd like to thank GE for the opportunity to be here to discuss this with you, as well as AutomationWorld for moderating today's discussion. So just by way of numbers, give you an idea of the size of Tacoma Power for those of you who are unfamiliar with us. We serve about 160,000 electric utility customers. We own 9 hydro facilities on 4 river systems. We are actually, my group particularly, we only look at hydro, and we only own hydro within this organization, although we do reach out to other types of power to retain our portfolio. Of that, there's 2,361 miles of transmission and distribution lines. There's 4 switching stations, 8 generation switch yards, 4 hatcheries, and 3 fish collection facilities. In addition to that, Tacoma Power employs approximately 780 employees. Of our customers, over 150,000 are residential customers, and over 18,000 are commercial customers. And I've really enjoyed my time at Tacoma Power, and it's interesting because we're a large enough company that we touch on several aspects of the power industry. We own generation, transmission, substations, hatcheries, and all that. But we're also small enough that our individual groups are asked to do a large variety of things with very little resources. My group in particular is responsible for integration, modernization, and maintenance of industrial control systems. And what that entails is power meters and other network sensor devices. There's temperature recorders, several PLC racks, actually over 120 PLC racks, over 20 VFDs. We've got several historian servers, several SCADA nodes, over 30 HMI clients, and other network devices such as motor starters, speed relays, dissolved oxygen monitors, and others. This is why it's so important, you know, and one of the things that I really want to point out is we have 3 engineers and 2 engineering technicians responsible for that, for all those facilities. And of the 9 hydro facilities, there are 23 hydro generators within that. And then in addition to that, there's several fish hatcheries, operations, and things like that. And a good day for automation is a day where there's really not anybody at our hydro facilities, where the thing runs autonomously and there's no problems. And usually we're called in if something were to occur, that an alarm or something were to be issued, and we need to investigate further. So we've been with GEIFix for over 10 years. In fact, when I was hired on the Tacoma Power, GEIFix was already established as our HMI SCADA system. On that HMI SCADA system, we have over 50,000 points. And that's, within our development lab and all the other facilities we own, that's about the historian point count. If you want to include all the points on our HMI SCADA system, it's probably going to range more along the 100,000 to 150,000 points. In our generation facilities, just to give you an idea of some of the things that we monitor, we have dams, lake levels. The dam lake levels, the megawatt values, megavar values, kilovolts, amps are just some examples of the things that we're monitoring. At the fisheries, we monitor flow, temperatures, pump statuses, fish counting, running gates, and other things. The HMI system, particularly at generation, is a local control, and we have a centralized energy management system that we interface with. And so there's really two forms of control. One is the local HMI SCADA system that we're responsible for, and then there's a centralized system that interfaces through the SCADA to control our generation facilities. On the fish hatchery side of things, we've added some additional capabilities for call-out. So if there's an alarm, it actually interfaces with the HMI SCADA system that results in a call-out if there's a critical alarm that they need to be called in for and to check out. The HMI system is used for trending and troubleshooting various issues that occur, as well as looking at historical data. When it comes time for regulatory reporting, we rely on having that data available. So with that small team that we have, one of the big questions is, should we move to a virtual environment? And the question really isn't, do you have to move to a virtual environment? Because I think that answer could be no, although, as the technology progresses, I think that more and more people are going to be jumping onto that. The question is, should you migrate to a virtual environment? And given our small group and our huge portfolio, we really had to ask this question to ourselves, because if there's an opportunity to reduce the overhead for our group, then we want to take advantage of that. So to answer this question, we're going to look at some of the advantages and disadvantages of virtualizing. And just to give you an idea, we have about 55 computers that our group maintains, and this is just the automation group, not Tacoma Power as a whole, between all our facilities. We've got 3 engineers to support that. And it's going to be up to each of you to determine whether the advantages outweigh the disadvantages. Now, I know Gimmi discussed some of the capabilities of the virtual environment. I'm going to give you some practical advantages and disadvantages as you approach your systems. So when you look at a traditional method, we use thick clients. And I want to just take a brief moment to define what a thick client is versus a thin client. A thick client, from a traditional standpoint, is just a full-blown PC. It's something you would buy from the store. It's got the hardware on it. Sometimes the operating system's pre-installed. That's a thick client. And what that entails is installing all your software on it. And if that piece of hardware were to be corrupt or something fail, it pretty much renders that useless, and you have to then buy a new piece of hardware to install on it. Versus a thin client, which is really a dummied-down version of a PC, and it's got an operating system on it, Windows embedded, if you've heard of it, and it's really dumbed down, very minimal capabilities, and typically it's used just to remote into a virtual environment. So I'm going to talk a little bit about that. When it comes to the thick client environment, some of the advantages that you're going to be looking at are that the teams, especially in the industrial control environment, are most familiar with this setup. When you get controls engineers on your team, they're not typically on board with the virtual environment yet. The industrial controls will lag quite considerably versus IT when it comes to that. So we're still primarily using thick clients. When we look at the disadvantages of a thick client, it's more prone to failure. And just to give you an idea of some of the failures we deal with, the most prominent failures is going to be a power supply or a fan in the PC. And we've gotten several calls from the plant saying, hey, we've got another system down. Either the power supply has failed or the fan has failed. It's pretty much a given. And that usually results in having to replace it. Unless you really want to put a lot of money into getting an industrial computer, which will probably have a much longer lifespan to it. Restoring or upgrading an entire system can take from several hours to several weeks. So if you have a system that has failed, we get the call that says, hey, the computer's failed. We're then going to have to put in the labor and resources to get a new system out there. And that typically entails installing Windows, if that's a part of that, installing Windows patches, installing iFix, installing other software updates. And so that takes a lot of the work. And when it comes time to doing testing in an HMI environment, you may find yourself a little bit nervous in wanting to try a new patch, because if you put a new patch on there and it breaks the system, with the thick client, you don't really have many options as far as hitting the undo button. And as far as the development space is concerned, we've got a development space. It's a very small space that we've been assigned. And when we look at the thick client environment, it requires several different PCs, servers, HMI software in order to mimic what we have in the field. And I'm going to talk about some of the advantages of switching over as far as that's concerned. We were able to reduce the space quite considerably. And you're also more prone to cybersecurity threats with standard operating systems. I mentioned earlier Windows Embedded, it's a dumbed-down operating system on the thin client. There's really not too much they can do as far as the thin client is concerned. And so there's some advantages there on the thin client side. So migrating to a virtual environment, one thing I want to note is this is page 1 of 2 of the advantages, so there's a lot to be said for that. One of the things is, Gimmi has already pointed out, it's less reliant on physical hardware. You can duplicate virtual environments very easily and load them onto any host system, and it's not dependent on the physical box. So when we look at a traditional standpoint, you may use some cloning devices like Norton Ghost or something like that, which requires very similar hardware, if not identical hardware, in order to make that work reliably. With a virtual machine, it's just a matter of copying the virtual hard disk, and then you can just store any hardware that's capable of a virtual environment. Restoring a system for disaster recovery is as simple as loading those operating systems on a virtual host machine. So let's say you have a plant and the whole thing was somehow became corrupt, or a flood came in and destroyed the equipment, and it's time to come in and replace that. Well, if you've got a copy of your virtual machine sitting in your development lab at a different location, it's just a matter of putting some new hardware in there and loading it up, versus a thick client, which is going to take you several weeks to get replaced. And what that's also going to allow you to do is free you up for handling other issues that occur as a result of any disasters that might happen. Development testing, I mentioned earlier at the thick clients that, if you install a patch, you get a little bit nervous, or a Windows update, because we don't know how the system's going to respond. With virtual environments, there's a very nifty tool, snapshots or checkpoints, depending on which virtualization software you're using. What this allows you to do essentially is test whatever you want, and then hit the undo button if you don't like the results. And then if you do like the results, you can accept those changes and then incorporate that into the field when you're ready. We've already made use of this, and it's become very helpful, and it actually encourages us to make sure we stay on top of patches when it comes to cybersecurity. We sometimes have to struggle between reliability and the security of the system, and now we have the best of both worlds with virtual environments. Duplicating similar systems is as easy as copying and pasting a virtual disk. I talked a little bit about that. When it comes time to a thick environment and you have to replicate multiple systems, you're either installing a lot of software over and over again, or you're using some sort of cloning which requires identical hardware. In this case, you just copy and paste the virtual hard disk and you're done. I mean, I feel like a mad scientist sometimes as I'm doing this work, because it becomes so easy. Enhanced support for legacy systems. So I talked a little bit about how the controls industry sometimes lags the IT industry, which means new software comes out from Windows, and the controls industry hasn't quite caught up to that new software yet. Either they're nervous because they don't know if it's going to catch on, or whatever the case might be. With a virtual environment, it allows you to move a legacy system to a new hardware if you wanted to. And a good example of that is we had some Windows XP systems where we wanted to retain as we moved to new hardware, and we were easily able to move that virtual machine to a new piece of hardware. Reduce hardware costs and failures since the thin clients replace the thick clients. Since we've moved to a virtual environment system for those facilities that have those, I haven't received a single call for something that has failed. We're just rejoicing over that right now. One central location to manage all your software and operating systems. So you have your host virtual machine hardware, which hosts all the virtual machines. All of your systems are right there, right at the tip of your finger. You can look at them. You can manage that software. From an IT standpoint, if you have cybersecurity that you're going to roll in, they're certainly going to appreciate that. I've been interfacing with our IT department a little bit, and they're very pleased with where we're heading as far as virtualization is concerned, because they're going to better be able to protect our cyber assets. And this is something that we tested. If you were to restart your host server, let's say your server needed an update and you had to restart it, what we found is that after we restart our host server using your normal restart routine, the virtual machines return to the previous state. So if you have certain screens open on your virtual machines, it's just going to open right back up to where that was. And this is on Hyper-V specifically, and I'm not sure if VMware works the same way or not. And for all of our facilities, now our development lab is reduced to a single server, and it hosts all of our operating systems. So for all of our various generation facilities, hatchery facilities, there's just one piece of hardware that houses all those operating systems. And we're going to reduce our thin clients to just a few of them. We don't have to have a full-blown development system anymore. Also, software keys are now a big thing within GE, and we're able to move software keys around very easily. So when you have a development lab and you're not going to be developing on all of your locations at the same time, you can just easily move those software keys around to the systems that you're going to be testing on. Security updates, malware protections, antivirus update controls are going to be easier to implement. This is something we're not quite at yet as far as having a system set up to do that automatically, but I'm told that it's going to be very helpful to have that by our IT department when it comes time to do that. Additional virtual instances can be created easily if there's a need. So an example of that is we have a biologist that says, hey, I need remote access to a system at a hatchery. We can easily create a new virtual machine that's just his own dedicated system that he can log into. Some of the disadvantages of a virtual environment: there's going to be a learning curve for automation and controls engineers. I've mentioned on more than one occasion that we're lagging a little bit behind the IT industry. And in return, we're going to have to look harder for new hires if that's something we want them to have the experience in, or we're going to have to be willing to train them up in virtual machines. The good news is, though, that as I move forward, it's really not that difficult, and I'm going to talk a little more about that. You're going to have a more robust and expensive server setup. So a lot of us aren't experienced with server and adding services and things like that. So there's going to be a little bit of that involved. You may have software that's not fully vetted out. This is becoming less of an issue. So when virtualization first came out, a lot of the industries weren't supporting virtual environments yet. But I think that more and more as the years progress, I haven't heard of any industrial control system software that isn't supported on virtual machine today. You might be unable to migrate all your systems to virtual environments at the same time. So we're going through a cycle where we're replacing all of our systems as we move forward. So you'll be supporting hardware, the old traditional thick client, and virtual systems if you have a lot of systems you need to maintain. So I think this picture on this slide does a pretty good job of letting you know, of the impression of what a virtual machine can be like. Because there's a vivid picture back there, but it's kind of blurred because we're a little nervous stepping into the virtual environment. It can be intimidating. I certainly was intimidated when I made the choice to try this out. But it's not as hard as you think. And I've showed you some advantages and benefits of virtual environments. And the advantages, at least from our perspective, certainly outweigh the disadvantages. And we made the call, we're going to try this out. So some of us have to make a business case for this. Quite honestly, from our perspective, the business case was very easy to push through. And the reason for that is that we already have a regular cycle for replacing hardware at our facilities. And we put a lot of labor resources into that, as well as purchasing new hardware. So really it was a matter of tweaking that process that we already had in place to include virtual environments. And so we use our justification was just the benefits that I've described. There's a small upfront investment when it comes to training up and getting used to the environment. But when we look at the long run, we're certainly able to save some time through efficiencies. And it also, cybersecurity is becoming a very big topic, especially in the power industry. And so when we rolled the cybersecurity benefits into that, it became pretty easy for them to make the call. So we secured the approval and the support of management, and then we added that to our regular budget cycle. And this is the approach that we took in incorporating the virtual machine. So our development lab currently consists of several PLCs as well as our HMI SCADA environment. And so we have simulated software in our PLCs that we're able to try out on our HMI systems. As far as approaching the virtual environment, we needed to start by creating a virtual machine with just Windows on it, and that's what we did. And it was very important to us that we have dual screen capabilities, so we wanted to make sure that was something. This was before we even got into GEIFix. We just wanted to see, can we create a virtual environment, and can we display it on a dual monitor to make sure that we've got visibility on a terminal screen. Because our end goal is to have the operators not even notice the difference between their virtual environment and the thick clients. And if we could make that happen, then I would consider that a success. So we did eventually get that virtual machine working. We used Hyper-V in our development lab, but that wasn't the only one we tried. We did try some some VMware as well, and I'll get a little bit into that. We installed GEIFix following that, and as far as that part is concerned, the soft licensing and installing GEIFix, that would be no different than a thick client. So once you have your virtual machine running, you just pretend like you're working on a thick client at that point and just get everything installed on there. And then we did a pilot deployment at our first plant. We had a low-risk facility that we were able to incorporate this into to try out with a backup plan to go to the traditional thick client if that was what would happen as a result. So we incorporated that virtual environment into the hardware software as a part of that upgrade schedule. Found that it worked out great. It becomes a little bit more network intensive, but as far as the network's concerned, it really didn't push it much harder. And then now we're in the process of refining best practices for deployment, standard operating procedures. So one of the things we're looking into right now is, for our HMI SCADA system, it would be how do we store the backup files to our SCADA environment for GEIFix using the backup restore tool. And now we have a virtual environment that we can essentially just make a copy of the entire system. And so it's a matter of how do we handle that, and we're looking into what the best methods might be. And now we're in the process of deploying it across all plants as a part of our regular cycle. And we're hoping that within the next 5 years, we're going to have all of our generation facilities virtualized. So this is a little bit of virtualization in action. I want to give you some of the side benefits that we have as a result of switching to virtualizing. We have much greater hardware reliability. Like I mentioned earlier, I haven't had a single call on our virtual environments as far as a hardware failure. We can create temporary view clients. So if you have a piece of hardware out in the system that's in use a lot and you're trying to keep other people's hands off of it, you can just create your own virtual environment, a temporary view client. Also, if there's a network capability anywhere at that facility, you can plug in a thin client and have access to any of the virtual machines, which is pretty neat. When a thin client were to fail, so let's say a thin client did fail for some reason, you're not going to have any loss of data because the virtual machine resides on the server itself and not on the thin client. And we're also able to combine other applications into our virtual system. So we have other devices, software requirements for other groups. We get to roll that into a virtual environment and specifically for their use. And that might be something that's separate from the plant control system, but we're still leveraging it for our benefit. There's also some reduced software costs too, and that's something I wanted to mention when it comes to virtual environment. We priced out thick client, I think it was the read-only GEIFix versus the thin client software license for development, and the development license for the thin client was cheaper for us than a thick read-only client. And so we're able to leverage those costs and get better capabilities out of our system as a result of that. So some of the best practices in learning, back that up one. One of the things I really want to push today is virtualization is very doable. There's really only one small piece that controls engineers and automation engineers need to figure out, and that is getting a virtual machine to work on a server. once that aspect is figured out, it's just a matter of doing business as usual. We actually did hire an IT consultant at first, and so I wanted to push that to maybe it's something worth considering. We had a consultant come out initially to show us some VMware capabilities for our system. And it was a little interesting because, like I said, the IT world is highly capable of virtualizing, and they're used to virtualizing very large systems. So when we had this guy come in to show us a little bit about how we can virtualize our industrial control system for a single plant, I think we had maybe 5 virtual environments that we wanted to set up, and he made the comment that that's the smallest he's ever seen. However, as small as it is, it's becoming very useful to us, and we've already looked at some of the benefits. An IT consultant can also, they don't have to maintain your systems. You can bring them in to teach you a little bit about it, and if you learn something, then you can pass that along to others as you move forward. So it was a big learning process for me when it came to virtualizing. I made the call that we're going to try this out, and as far as the training is concerned, I kind of reached out to the group and taught them a little bit myself after learning it, and they're on board now, learning more every day. You want to be able to test, pilot, refine the process, and then overcoming the learning curve for controls and automation engineers, developing those standard operating procedures that we talked about for deployment. We actually have instructions set up on how to install the Windows operating system on the server, how to install virtual environments to put together virtual environments, and installing GEI fix on those environments, and the licensing and all that. So we've got a pretty good system set up as far as getting an environment put together. And then deploying during your regular upgrades. So hopefully you guys out there already have a system set up for deploying your systems, upgrading hardware, and you can roll the virtualization into that. I'm going to hand it back to Jimmy to give you more information on the topic.
Thanks, Ozan. So I just wanted to kind of finish off just letting you know there is some other information out there you guys can access. Ozan went through some really good key points. Just as a takeaway, ISA does have some great resources that you can access. As well, we also have our virtualization guide that GE Digital produced that you can access off the registration page. And that has a lot of good information just on different approaches and different benefits from virtualization. So with that, we're going to go to some questions.
All right. Well, thank you, Jimmy, and thank you, Ozan. That's a fascinating presentation. It's really interesting to see how this concept is being adapted by the industrial automation space and what all it really enables. It's really interesting, and I know we're going to be hearing a lot more about it over the coming years, really, as this gets rolled out across industries. And needless to say, with the level of this topic and the newness of it, at least in the industrial space, relative newness, I should say, there's lots of questions going on about it. We've had lots of questions roll in during the presentation. So I'm going to kind of try and work through these. Some of these questions are for both of you. Some of them are more for one than the other, and I'll try and make the best sense out of that as possible. One of these, we had this pop up a couple of times in different iterations, and this question I believe would be best suited for Jimmy. It's asking, is there any difference in speed when you're working with virtualization versus working with it directly in the traditional sense? Jimmy?
Thanks. Yeah, with virtualization, there's always some impact that's dependent on the available resources. Kind of the chart I reviewed earlier talked about, how you could have multiple cores, and in most cases they are underutilized. So, for the most part, as long as you stay within the constraints of the resources that you have on the system, the impact is minimal. We've seen the software perform pretty much almost the same as you would have on bare metal in many cases. Obviously, if you overload the system and starve the different virtual machines of resources, then you'll start seeing impact. So sizing becomes really important for that.
Okay. See, this next one I believe is more for Ozan. It's asking, obviously you referenced in your presentation that you have a small team you're working with, but it's a very large system overall that you're controlling. Would you say from your experience that virtualization is really more for large system deployments, or can this be equally suitable for smaller? What would be your take on that?
Well, I would say that, as the larger the system, the more you're able to leverage the virtualization. For us, like I mentioned that we've got some very small virtualization needs at our facilities. For each plant, we may have upwards around 5 to 7 HMI PCs that need to be virtualized. And from an IT perspective, that's a very small number. But when we look at leveraging for efficiency and making sure that we're freed up to do other work, we found it extremely useful to have the ability to virtualize. We also don't leverage as many resources as the IT world might need. One of the big things we wanted to do as far as virtualizing is avoid a domain server, because then we start to get more into the IT world when it comes to that. So we were actually able to incorporate virtualization without including any domain servers or anything like that. And I did mention the consultant was shocked that we only had 5 virtual machines initially that we were looking at incorporating, and we were very adamant about making sure that the operators saw what they've been saying for years, that they wouldn't even really notice a difference. So I would say no, it's not just for large systems. We've got small systems. Overall, we've got a lot of systems, but they're all being managed separately at different facilities with very small number of virtual machines, and we're leveraging that to our advantage still.
Okay, thank you. Interesting. All right, Jimmy, I believe this next question is most for you. I'm going to combine a couple of questions that have come across the channel here. One is asking, does GE recommend virtualization for HMI SCADA systems in general, and is there a certain virtualization software that you recommend?
Yeah, again, it always depends on the situation and the application. So obviously, if you've got a very small system, that's a single node, it may not make sense. Certainly as things grow, there's some definite advantages to virtualization, so we would recommend it in some of those cases. Obviously the case like we've reviewed today. So it really does depend. I guess some other considerations you may want to take on there, things like, and Ozan kind of referred to a little bit, he got the IT specialist in and something like that, but ultimately somebody will have to own it. So if you don't have the resources in terms of people that can manage it, it would be taking on something that, might be foreign, then it might be something you may not want to do. But really it's about having somebody to own it. Can you gain benefits with multiple systems running on the same piece of hardware? Obviously if they're standalone panels, that that may not be the case that you want to use it in. So I think, again, it kind of depends on the situation.
And what about the virtualization
yeah,
software?
sorry, I missed this. Yeah, sorry, I missed the second part of that question. In terms of, we don't really recommend any specific ones. I mean, all I'll really comment there is, probably the 2 most common ones are the VMware platform and Hyper-V from Microsoft. Those are definitely the ones we see used most in the industry, and I think that probably would go with the overall industry, what we see even in the IT industry. I know there are other ones out there, I'm just not as familiar with them.
Okay. Now, Ozan, I'm going to combine a couple of questions I'm seeing come across quite a bit here for you as well. One of them is asking, how did you choose your virtualization software, coming off of Jimmy's comments there, and how did you test all this before deployment?
Okay, those are good questions. We're not IT, obviously, and so when it came to deciding what virtualization technique do we want to approach first, Jimmy mentioned that in the industry that primarily there's GE and Microsoft, or sorry, the VMware and Microsoft for virtualizing. So we did limit our 2 options to those pieces of software. And since they both had really good resources, both from an industry perspective and a self-help perspective, that's why we did that. The reason why we arrived with Microsoft, quite frankly, is that we were able to set up a virtual environment that works without a domain server. Just in our initial research, we couldn't find a way to do that with VMware. And like I said, we really wanted to avoid that, because when we get into domain servers and stuff, we're kind of getting into territory that's just really uncomfortable with us. And working with Hyper-V also means that you're working with an interface that you're already used to. Our group's already used to the Microsoft server interface. We're used to the Microsoft operating system, and it's all rolled into the same software that way. And when we work with the work in getting Hyper-V up and running was basically limited to adding it as a service to Server 2012. As far as how did we test before deployment, we've got a 10 by 20 cubicle space that we set up for development. We have a soundproof server rack that housed the development server. All we needed was some PLC hardware that interfaces with our HMI system, a thin client, and a server to work with to perform the testing. It basically consisted of setting up the server, installing the Hyper-V on it, and then creating a new virtual environment within Hyper-V. And I'll just make a note. There's a lot of resources on the. I mean, we live in an information age. We can pull up Google anytime we want. If we see an error that doesn't make any sense to us, you get to Google that and figure out how people got around it. So Google was my best friend during this process. I found some very good self-help type articles, both from Microsoft website as well as other tech-savvy people on how to create a new virtual environment. And then we installed the software onto a virtual environment once we got it and tested it like we would a thick client. So our process for testing really wasn't much different than our traditional method. It was just a matter of getting the virtual machine set up.
Okay, interesting. All right, let's see here. This one, I think this one is more suited for Gimmi here, and it's asking, in your experience, in rolling out virtualizations of HMI SCADA, have you ever seen the concept and process of virtualization not work out? Is it ever been not really suitable or had any issues?
Yeah, there are some cases. They're usually fairly very few, but there are still some cases where the systems are relying on really a hardware layer, like for example, utilizing hardware communication cards and things like that. Those definitely become more of a challenge because you do have that separation between the hardware layer and the operating system. So that would be one example that I've seen. And those are typically legacy systems. So again, there's not a lot out there. Most people use Ethernet communications nowadays for a lot of devices. But again, they are out there. There's lots out there in terms of legacy systems still. So that definitely becomes more challenging.
Okay. Now, Ozan, this one's, I believe, is best suited for you. You talked a lot about, as you're looking, to hire people, looking out, with this is now with your reliance on virtualization, how that's one of the abilities you're looking for in them or the need to train them. As you started into this, in virtualizing your HMI SCADA environment, did you have to send your existing staff to courses to learn how to deploy virtualization, or did they learn along the way with the implementation? How did that work?
I'm really glad you asked that, because the answer to that is no. We haven't had to send a single person to learn about how to deploy virtualization. The initial task was to go in and have one person work on it, sort of like a research and development perspective. Try it out, learn as much as you can in the process, and if the system worked out, to just relay that information to the group, sort of on a progressive sort of basis. And that's pretty much how we worked. I was involved in incorporating the system, trying this thing out. I had a lot of interest in making it work. And once I figured out my niche and I got the thing working on Hyper-V, it was very easy to pull in individuals one at a time, as they're, because as far as the cycle is concerned, you can assign different employees to that work and just train them up as they go. And right now, of the 3 engineers that we have who are responsible for going in and upgrading that, they've become very comfortable with the virtual environment. There's still a little bit of a learning curve as far as remoting in and setting up thin clients and stuff like that. It's a little bit different than traditional, which is expected, and that's going to happen. But very easy to train internally as well. So if you're looking to hire somebody for the purpose of virtualizing, if you don't have a virtual environment, you may want to look for that skill. Is it necessary for a new controls engineer? I would say no, as long as somebody is able to train them up, at least internally. And I think in the industrial side, I think it's pretty hard to look for training too for virtualizing, because that was one of the things I looked into. So I think we're going to actually have to start training internally, or people are going to have to take advantage of the industrial controls environment and cater to those needs. And I know there are some companies that have started doing that.
I guess the whole space is still relatively new for that, so we'll see how that develops out over the next several months or a few years. Let's see here. I think this one's next question is a little more suited for Gimmi here. It's asking if you have any tips on how to reduce the risk associated with the use of a virtual server.
Yeah, I mean, I'm assuming this is coming just in general from securing the system. In terms of, I guess, from an architecture perspective, it's really not much different than bare metal, because at the end of the day, you know, whether you have 5 pieces of hardware running side by side or 1 piece of hardware running 5 virtual machines, the security challenge is likely the same. You know, there's definitely some guidance out there in the industry from, you know, for things like IT security models, where you'll still want to isolate your different layers of your network, you know, to help reduce the threat from external attacks and things like that. It is really a topic on its own, but, you know, I think from an architecture perspective, it really does become the same challenges as it would be as if it was bare metal. So I guess I would just recommend a strong IT security model, no different than you would do for bare metal. And it really is a topic on its own that I think we have covered in the past as well.
Okay. All right.
Yeah.
All right. Looks like we got time for maybe one more question here, and let me scroll through here. Let's. It's Ozan. This one's for you here. It was during your presentation you referenced how even though you've got a very large deployment of what you're controlling, you're doing this all with a very small team. And the person asking this question is saying that they're also operating with a small team, and that's their biggest challenge around the idea of moving toward virtualization. Do you have any recommendations for this for a small team looking to move towards this?
Well, I guess my first recommendation is if you've got a small group with a lot of different systems that you need to maintain, virtualizing is probably going to be a really good friend of yours. That's one of the reasons why we did switch to virtualizing, is because we needed to find a more efficient way of maintaining our system so that we can focus on other things as they came up. Having a small team, yes, there are going to be challenges to that. It's very difficult when you've got, I mean, we're dealing with this right now. We've got several capital projects going on, several different little projects that we need to take care of. And how do you fit the time in? Well, you know, someone's going to have to make that call and putting in the effort up front. However, I think that it's worth doing, because if you put that effort up front, it's going to save you a lot of time down the road, and you're going to find yourself being able to work on projects because you don't have to deal so much with the hardware aspect of the SCADA system. It's also worth reaching out to other people in the industry. I know for me that was a struggle because there aren't many people, especially in the power industry in the Northwest, who have that experience. I've called up several companies and asked, hey, are you considering virtualizing? Are you doing it? They said, yeah, we considered it, but we're not doing it. But now they've got a resource, so if they start doing it, they can reach out to me, and I'll be more than happy to share a little bit about my experiences there. And you know, I welcome a call now and then with peers that have those questions, and I'm certainly not shy to reach out and ask others. Also, don't be afraid to, you know, I talked about having an IT consultant come in earlier in the beginning, the start process of this thing. It didn't cost us very much. It cost us, I think, under $5,000 to have the consultant come out for a few days, and the cost actually included the cost of the server, the Dell server that we purchased. And so it's if you find the right person, they can come out and show you a little bit about it. They can either scare you away, or they'll help you find a fit that works best for you. So I certainly encourage you to do that as well.
All right. Well, thank you very much. Thanks to both of you, Ozan and Gimmi. I appreciate you spending the time with us to explain the concept of virtualization for HMI SCADA today. And I'd like to thank all of you for joining us and listening in, and we'll see you soon. Thank you.